Large iron gyroid 1.3 x 1.0 cm. Credit ALCHEMY EPFL CC by SA. Swiss researchers have pioneered a method of cultivating metal out of water-based gel, an innovation that promises valuable applications in energy technology. The concept aims to power the production of unique sensors, biomedical devices, or energy conversion and storage components. Scientists at the Ecole Polytechnique, Fédérale de Lausanne in Switzerland have created dense high-strength structures by injecting hydrogel with metal salts of various minerals like iron and copper. Early results show materials 20 times stronger with much less shrinkage than earlier methods. As novel a concept as cultivating metal sounds like it's actually been done before, but challenges presented themselves which could not be overcome in these previous experiments. They involved fat photopolymerization, a type of 3D printing that sees pouring a light reactive liquid resin into a container and then solidifying specific areas with a laser or ultraviolet light to create a shape. However, because this method only works with light-sensitive polymers, its practical uses are limited. Darrell Yee, who leads the Laboratory for the Chemistry of Materials and Manufacturing at EPFL School of Engineering, said these earlier approaches have major flaws. These materials tend to be porous, which significantly reduces their strength, and the parts suffer from excessive shrinkage, which causes warping, he told his university press. To address these issues, Yee and his team have introduced a new approach described in their paper published in Advanced Materials. Instead of hardening a resin already mixed with metal compounds, the researchers first 3D print a framework using a simple, water-based gel known as a hydrogel. They then soak this blank structure in metal salts, which are chemically converted into tiny metal-containing nanoparticles that spread throughout the gel. Repeating this process multiple times allows them to create composites with very high metal content. After 510 of these growth cycles, the remaining hydrogel is removed through heating, leaving behind a dense metal or ceramic object that precisely matches the shape of the original printed gel. Because the metal salts are added only after printing, the same hydrogel template can be used to make a variety of different metals, ceramics, or composite materials. Our work not only enables the fabrication of high-quality metals and ceramics with an accessible, low-cost 3D printing process, it also highlights the new paradigm in additive manufacturing, where material selection occurs after 3D printing rather than before, Yee summarizes. For their study, the team fabricated intricate mathematical lattice shapes called gyroids out of iron, silver, and copper, demonstrating their technique's ability to produce strong yet complex structures. To test the strength of their materials, they used a device called a universal testing machine to apply increasing pressure to the gyroids. News from material sciences, cement supercapacitors could turn the concrete around us into massive energy storage systems. Our materials could withstand 20 times more pressure compared to those produced with previous methods, while exhibiting only 20 shrinkage versus 60-90, says PhD student and first author Yaomin Zhai. The scientists say their technique is especially interesting for the fabrication of advanced three-dimensional forms that must be simultaneously strong, lightweight, and complex. For example, metal catalysts are essential for enabling reactions that convert chemical energy into electricity. Other applications could include high surface area metals with advanced cooling properties for energy technologies. 3D printing advances 3D printed aluminum alloy set strength record on path to lighter aircraft systems. Looking ahead, the team is working on improving their process by further increasing the density of their materials. Another goal is speed. The repeated infusion steps, while essential for producing stronger materials, make the method more time-consuming compared to other 3D printed techniques for converting polymers to metals. We are already working on bringing the total process and time down by using a robot to automate these steps, Yee says.